Good afternoon, technology teachers. Timo Orange presenting. So, yet again, we're busy with a lesson on Perplexity AI. So, populate a grade 9 technology lesson on Ohm's law quantitatively as voltage increases, current increases if resistance is constant. Action research, testing Ohm's law practically, aligned with CAP's curriculum, and include the 5E lesson with videos as resources, please. So I'm currently on the Perplexity AI site, and this is what Perplexity populated. As you can see, YouTube video resources and other resources. And with the introduction of the lesson, Perplexity recommends in this lesson we will learn about Ohm's law, which is a fundamental concept in electricity. Ohm's law states that as voltage increases, current increases if resistance is constant. We will explore the relationship quantitatively and test it practically. This lesson is aligned with CAP's curriculum. So let's move to the engage section. We will start the lesson by watching a video that explains Ohm's law, and here is a YouTube video that can be used for this purpose. So Perplexity supplies us with the particular video that the teacher needs to use with this engage section on the site. And with explore, to explore Ohm's law, we will conduct a practical experiment. Here are the steps. Set up a simple circuit with a battery, a resistor, and an ammeter. Measure the resistance of the resistor using a multimeter. Measure the voltage across the resistor using a voltmeter. Measure the current flowing through the circuit using an ammeter. Repeat steps 3 and 4 for different values of voltage by changing the battery. Record the values of the voltage, current, and resistance in a table. Plot a graph of current versus voltage. Calculate the slope of the graph, which is equal to the resistance of the resistor. Compare the calculated resistance with the measured resistance. Now we get to the explain stage. Now that we have conducted the experiment, we can explain Ohm's law quantitatively. Ohm's law can be expressed mathematically as where V is the voltage, I is the current, and R is the resistance. So volt equals current times resistance. This equation tells us that if the resistance is constant, then the voltage and current are directly proportional to each other. In other words, if we increase the voltage, the current, we will also increase proportionally. The current will also increase proportionally. With the elaborate section, to elaborate on Ohm's law, we can discuss some real-world applications. For example, Ohm's law used in the design of electrical circuits, such as in the calculation of the appropriate resistor value for an LED. Then Ohm's law is also used in the design of power transmission lines, where the resistance of the line must be taken into account to assure that the correct voltage is delivered to the end user. And then we get to the evaluation section of the lesson. To evaluate the students' understanding of Ohm's law, we can ask them to solve some numerical problems. And here are some examples. Number 1, a circuit has a resistance of 10 ohms. Now, if the voltage across the circuit is 20 volts, what is the current flowing through the circuit? Number 2, a circuit has a current of 2 amps flowing through it. Now, if the resistance of the circuit is 5 ohms, what is the voltage across the circuit? So a circuit has a voltage of 12 volts across it. If the resistance of the circuit is 3 ohms, what is the current flowing through the circuit? And then to the conclusion, Ohm's law is a fundamental concept in electricity that describes the relationship between voltage, current, and resistance. As voltage increases, current increases if resistance is constant. We have explored the relationship of quantitatively and tested it practically. Ohm's law has many real-world applications, and it is used in the design of electrical circuits and power transmission lines. And so now we get to the end of the lesson, and this is more the application, the practical application to the learner with hands-on activities. So how can action research be used to test Ohm's law? So now Perplexity supplied us with the resources again, and action research can be used to test Ohm's law in the grade 9 lesson by conducting a practical experiment and analyzing the results. Here are the steps for an action research project aligned with CAPS. Engage, introduce Ohm's law and its importance in electrical circuits. Show a video that explains Ohm's law, such as the one from Tech Engineering. Now, as you can see, there's the one on Tech Engineering. Explore, conduct a practical experiment to test Ohm's law. Follow the steps outlined in the Cambridge University Press Teacher Guide of the then analyze the data and explain the relationship between the voltage, current, and resistance, and use this particular equation to calculate the resistance of the circuit. Discuss the implications of Ohm's law in the design of electrical circuits and power transmission lines. To elaborate on the real-world applications of Ohm's law. Show how Ohm's law is used in everyday technologies such as smartphones and computers. Use virtual lab simulations such as those provided by labs. Now, Perplexity supplied us with a virtual lab simulator that the learners and the teacher can use. Evaluate the students' understanding of Ohm's law by asking them to solve numerical problems or design their own circuits. Use the Labster Virtual Lab, and I will play a video where we demonstrate the virtual lab. Let's play this video.
In this video, we're going to take a look at Ohm's law. So by the end of this video, you're going to be able to explain the relationship between voltage, current, and resistance, and also to be able to apply Ohm's law to solve for either voltage, current, or resistance in any kind of problem. Now, what is Ohm's law? Well, Ohm himself was a scientist that observed the many relationships between voltage, current, and resistance. Remember, voltage is like the force pushing our current through the circuit, and then our resistance is providing or slowing down both the voltage and the current in our circuit. Now, what is Ohm's law? So Ohm's law is basically a mathematical relationship to describe how voltage, current, and resistance are related to one another. So the equation that we need is V equals I times R. So V is the voltage, and that is in the units of volts. I is the current, and that's in the unit amps. And then R in this equation is resistance, and that's in the unit ohms. So we can, if we have two out of these three variables, we can rearrange our equation to solve for the other third one and figure it out just from knowing two out of three of these. So you can have V equals I times R, or if we rearrange for I, we're going to have then V over R. And then if we rearrange for R, we'd have V over I. So let's take a look at how this works in a problem. So we've got an example here. We have a current of 4.0 amps that flows through a resistor of 40 ohms. What is the voltage of the circuit? It It's always a good idea to start out by listing what we know. We know that the current I is 4.0 amps. We know that the resistance R is 40 ohms. We don't know what V is. That's what we're trying to solve for. So using our equation V equals I times R, if we substitute in I is 4.0 and R is 40, and if we do this problem here, then we get 160, and because we're solving for V, that's volts. Okay, so that would be our answer. The voltage is 160 volts. Looking at a second example, we have a voltage of 60 volts flowing at a rate of 5.0 amps. What is the resistance of the circuit? So let's start out again. We know what voltage is, that's 60 volts. We know what our current is, I, which is 5.0 amps, and we're trying to solve for R. So we do need to rearrange our V equals I times R. If we divide both sides by I, then R is going to be equal to V divided by I. Okay. And so if we substitute in our numbers, our voltage is 60 volts. Our amps is 5.0 amps. And solving this gives us 12. And remember, since this is our units are going to be in ohms. So that's 12 ohms. Okay. So you can solve for any variable using Ohm's law as long as you know the other two ones.
So here we have the Ohm simulator. And so this presenter is going to give us a quick overview of the Ohm simulator and navigate us through the simulator. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, grade 10? Today, inshallah, I'm going to re-explain the experiment we've already taken in the class, which is verifying Ohm's law for ohmic conductor. So you have this one already. It's uploaded in MS Team file section. I want you to download it. You read the procedures really carefully and open the simulation. So first step, you have to open the simulation. Here I have opened the simulation. As we know, Ohm's law gives you a relation between voltage. If I increase the voltage, what will happen to the current? The current as well will be increased. So in the experiment, I created a table for you. I want you to keep the resistance fixed at 500 ohm. Each time we're going to play with the voltage and record the value of the current. So we start with 0.5 volt, okay, and record this value. It's 1 milliamp. And then we'll go to, so we record it here. You have to create Excel sheet. I've already shared with you this Excel sheet. Okay, so here you have to write the values here. So current 1 milliamp. Then increase the value of the voltage, go to 2 volt. Okay. And record the value of the current. Here I have 4 milliamp. 4 milliamp. Finish the experiment, finish taking all this measurement type. Next step, what we need to do from this experiment? We need to verify Ohm law. We need, after we're done, to draw a relationship between voltage and current. We should get a straight line because it's ohmic. It's obey Ohm's law, so I should get a straight line. As we know, the slope of this straight line should give you what? The resistance. So I know is voltage, V, we know we studied V, equals what? I times R. So if I draw a relationship between voltage and current, I should get a straight line. The equation of a straight line y equal mx plus b. I don't have b, y-intercept. I started from 0, so b is 0. V, it's what my y-axis. I, the current, is the x-axis. So R will represent what? The slope. The slope, which is rise over run. So R, V over I, or the slope of V versus I. So second step, I need to convert from milliamp to amp. So divided by 1000. So I'm going to write equal. Go to the 1 amp, put the mouse on it. Okay, forward slash 1000 divided by 1000, hit enter. Okay, go back to the same cell. You see this point to the right corner of the cell. Put the mouse on it till the mouse becomes like a plus sign, and then drag all the values down. Now I need to draw a relation between volt.
Okay, so there we have the presenter just navigating us on the simulator for ohms. And I thank you. Thanks a lot.